Hello again. So this video is probably going to be the longest for this playlist purely because questions 7 and 8 are probably the meatiest questions on the paper. But let's try and get through this in an orderly fashion then. Unfortunately, given the way it's printed, I may struggle to get both of these on the page at the same time. So having this and the questions may be a bit of a nuisance. So there may be a bit of swapping back and forth, but I'll see what I can do. So for now, I should be able to do this, but when we get to these later ones over here, it may be a bit more of a nuisance, but I'll see what I can do. Right, so circle the earliest decade in which anyone included in the histograms would have been born. So if we go back to this very quickly, so look at these histograms here. So the oldest for both of them is 90. So what we do is this is given in a range. So we pick a range and we go for the starting value or the end value. So I would go for the start value personally. So the oldest person on here is 90. So we're going to go back 90 years from 2001. So that is going to be 2010, I believe. I got a calculator. What am I doing? So going back 2001 minus 90 years is going to be 1911. So it's going to be this one here. It's comparing the start values. So it's going to be this one here. Right. So from Dariel's histogram, the population of under 50s in Wales is 1,870,000 in 2001. Calculate the increase in the under 50s from 2001 to 2011. So we need to find the population of under 50s in 2011 and then just take the difference. Right, so the frequency on a histogram is given by the area. Let me just check my camera. Can everyone see down here? Okay, yeah, okay, we should be good. Right, so 50 is here onwards. So we are doing these areas here. And luckily, this is a length of 10, this is 10, this is 10, and then this is 20. So these really shouldn't be too hard to calculate. Right, so this one here, width of 10, and it has a height of 3 above 40,000. So it's going to be 43,000 times by 10. So that's going to be 430,000 for the first one. And then this one here, again, width of 10, and it has a height of 360, so it's going to be 360,000. Again, just the area of them, because it's times by 10, it's nice and easy. This one here, width of 10 again, and this one's at 40,000 exactly, so it's going to be 400,000. And then this one here is a width of 20, and it's going to be 36,000, same as the other one. So 36,000 times by 20. So 36 times 2 is 72, so it's going to be 720,000. So now using my calculator, I can add these up like so. So 430,000 plus 360,000 plus 400,000 plus 720,000. I get it to be 1,900,000. And so the difference now, so once the increase, so it's 1.9 million. Take away 1.87 million. So it's going to be, so if I write this as this, it's going to be, I've written this wrong, my apologies. So that's 1.91. So it's 1.91 million, take away 1.87 million. So it's going to be 0.04 millions or 40,000. It's 40,000, that's the difference. Right, so the 60 to 69-year-olds saw the biggest increase in population from 2001 to 2011. Calculate the percentage increase. Okay, so again, can everyone see these? Okay, so if we go to the 60, again, this is a width of 10, so nice and easy. So in 2001, there were 30,000 times 10, so 300,000. And then in 2011, there were 38, so 380,000. So this is a simple percentage change. So 300,000 times by something got this to 380,000. This is a simple after divided by before, really. So the multiplier we're looking for is 38,000 divided by 300,000. Which is going to be 1.2666 recurring. So this is a multiplier representing a 26.6 recurring percent increase, but it asks us for the nearest whole number, so it's a 27% increase overall. Well, for the final answer anyway. Right, so these part 2 questions, these don't require the graph, so I can do these quite comfortably now. I can just leave the graph at the side. So age group 90 and over, is you're given this data here. This data in this table is also available to Danielle. I'll explain why Danielle didn't include it in the histogram. It's basically because it says and over. So if it's over, how do you know how wide to draw your graph? To draw your bar essentially. So if I were to add it to this, where would it end? Because it doesn't actually have an end point. That's the problem there. So no upper bound. And I would pose the question, how wide to make it? So the number of 40 to 49-year-olds in 2011 was different to the number of 30 to 39-year-olds in 2001. Give a full explanation for what could have caused this. So outside factors, so migration, for example, so people could have moved into Wales. We should look at the graph really. So in 2011 and 2001. So that it's for 40 to 49-year-olds. So this graph here and this graph here. So it's actually increased. So people of migration, so in. People have migrated, so people in. If it wasn't increased specifically, you could say things like leaving, so immigration, or you could say people dying, that sort of thing. The reasons why it wouldn't be the same. Okay, moving on then. So this next question then. Again, like I said, 7 and 8 are probably the beefiest questions here, and we'll get through this. Right, so there's a cargo ship. She's planning her next voyage. She's been employed to deliver 3 times 10 to the 5 tons of sand. She needs to know the volume of sand before the sand is loaded onto the ship. She has been given the following information about the sand. Calculate the number of grains of sand in that many tons of sand. And give your answer in standard form. So we're going to do this by the mass. So we just need this by comparison, essentially. So we're told that the mass of 1 grain is 1.2 times 10 to the negative 3. So we essentially want the total mass, and then we're going to work out how many of these fit in this. And then every one of these that fits in is 1 grain of sand, essentially. So 3.3 times 10 to the 5, but it's in tons. So for it to be a fair comparison, this needs to be in grams, right? So what we're going to do is we're going to convert this into grams. So there are 1,000 kilograms in a ton. So we times this by 1,000 to move it into kilograms. So 3 times 10 to the 8 kilograms. And then to get this to grams, we times by 1,000 again. So it's 3 times 10 to the 11 kilograms. So then, to compare this then, so it's 3 times 10 to the 11 divided by 1.2 times 10 to the minus 3. And you can do this without the calculator, really. It's 3 divided by 1.2. So how many 1.2s are there in 3? It's 2.5. And then with division of standard form, we just simply subtract the powers. So 11 minus 3, so it's times 10 to the power of 14 grains. Calculate the volume of 3 times 10 to the 5 tons of sand, but give it in meters cubed. So using our answer up here, so each grain, there are this many grains, and we know that the volume each one occupies is 0.32 millimeters cubed. So 2.5 times 10 to the 14 times by 0.32. So 2.5 times 10 to the power of 14 times by 0.32. So this is going to be 8 times 10 to the power of 13. And we note that this was millimeters cubed, so millimeters cubed. And now we just have to convert our answer to meters cubed. So similar to what we did before on a previous question, we just look at the normal conversion, but it's that conversion cubed. To go from millimeters to centimeters, it is a divide by 10. So to do it from millimeters cubed to centimeters cubed, you are going to divide by 10 cubed, so 1,000. And then to go from centimeters to meters, it's divide by 100. So to go from centimeters cubed to meters cubed, it's going to be divided by 100 cubed. So essentially, we're going to divide by 10 cubed, and we're going to divide by 100 cubed. So dividing by 10 cubed first, so dividing by 1,000. It's going to be 8 times 10 to the 10, and that's going to be in centimeters cubed, and then dividing by 100 cubed. So dividing by 100 to the power of 3, it's going to be 80,000 according to my calculator. And then I can put that in standard form quite comfortably. So the point wants to be here, so it's 8. And then we could just think of this as to the power of 9, right? No. So divided by 100 cubed. So I get this to be 80,000. So that's going to be 8 times 10 to the power of 1, 2, 3, 4. So 8 times 10 to the power of 4 meters cubed is your answer there. Right, almost done. So this says here it's a sketch. That means you're allowed, it's a rough drawing. You don't need to use a protractor, essentially. So from port A, they set sail due south to port B. So they go south to port B, which is here. From port B, they set sail east to port C. And again, if you don't know your northeast, southwest, you really should not be saying the paper. And then from port C, sail on a bearing of 318 back to port A. Right, so by the definition of bearings, if I draw my north line, this full angle is 318 degrees. So we know that this 3/4 turn is 270. So therefore this must be 48 degrees. That makes sense. It must be 48 degrees. So if I draw a cross section of this over here very quickly, so it's 48. And we're told that they set sail for 200 meters going from A to B. So A, B, C. So this is 200. And we're asked for this length here. So I'll call this length just L. So we have a couple ways we can do this. So this being a right angle because it's north to east, you could use the sine rule and compare these because you've got a pair. But I think the easier thing to do here is just note that you've got the opposite and the hypotenuse. So it's sine. So sine of 48 equals 200 over L. So therefore L equals 200 over sine of 48. So 200 divided by sine of 48. And that's going to be 269.12. And was that 200 kilometers? Yeah, it was 200 kilometers. So this is 200 and that. Perfect. And I do believe there is a small part C for this. So the last time the cargo in the ship was unloaded, in port B, it took 3 cranes 45 hours to unload 250,000 tons of sand. Port B now has 5 cranes. Calculate the time it will take 5 cranes to unload 300,000 tons of sand. You can assume that all cranes unload sand at the same rate and all of the conditions remain the same. Give your answer in hours and minutes. Okay, so we're told initially that 3 cranes can move 250,000 tons of sand in 45 hours. And the objective is to get to 5 cranes, and then this is 300,000, and we'll look at the time. Right, so first thing then, I'm going to make this 1 crane, so I'm going to divide this by 3. So I note that the relationship between the number of cranes and the number of tons of sand would be direct. So this would be a direct proportional relationship because if I've got less cranes, I can move less sand. And if I've got more cranes, I can move more sand. Similarly with the time, it's an inverse proportion relationship purely because if I've got less cranes, it's going to take me longer. It's going to take me more time and vice versa. So I'm going to divide the number of cranes by 3. That's going to triple the amount of time it takes. So that's going to be 135 hours. To move the same amount of sand. And then I'm going to times this by 5 to get to 5 cranes. So that means this has to be divided by 5. So 135 divided by 5, so 27 hours. So it takes 27 hours for 5 cranes to move 250 tons of sand. Okay, so generally speaking, this next bit you can do in various ways depending on your skill level, really. So you want this to be 300,000, and if you're competent, you can see it's adding 20% on, so you can times by 1.2 and do something similar to what we've been doing here, if you can see that. But I understand that not everybody can see that. So what we'll do is we will divide this by 5 to get this to 50,000 tons. So now this is already at 5 cranes, so we have to keep it how it is. So what's the relationship between the amount of sand and the time? If I decrease the amount of sand, it's going to take less time. So this is also divided by 5. So 27, I'll just keep it as 27 over 5. It's much simpler. And then we're going to times by 6 to get this to 300,000. So that keeping the 5 cranes here. So 300,000 tons and then timesing by 6. So 27 times by 6, it's going to be 162 over 5 hours, 5 cranes, and this is what we're looking for here. So 162 divided by 5 is 32.4 hours. So it is 32 hours, and then 0.4 of an hour, so 60 minutes. What's 40% of 60 minutes? And that's 24 minutes. So it's 32 hours and 24 minutes.